Hello friends, welcome back to my class. In today's class, our topic would be free body diagram, or we say it as FBD. So what is free body diagram? So before going to the definition of free body diagram, let us see some example of it. See friends, let us imagine this is a table. This is a table. On that table, we have a ball. We have a ball. So, this one is my table and this one is my ball. So, according to Newton's third law, every action has equal and opposite reaction. So if at all weight of this ball is acting downward, because weight of an object always act downward, okay, due to its gravity. So if the weight of this ball is capital W, so if at all this weight of the ball is acting downward and it's acting at a point on the table, this will be my action, okay, or else this will be my weight, because weight always act downward. And what is formula for weight? W is equals to mass into gravity. W is equals to mass into gravity. Now FBD. So if at all the weight of this ball is acting vertically downward, that could be my reaction, then obviously the reaction will be given by this table onto the ball. Reaction would be given by the table onto the ball. So here, this will be my reaction. This will be my reaction. And remember that force is a vector quantity. Force is a vector quantity. Then the magnitude of this action or weight should be equal to the magnitude of this reaction. Both would be in opposite direction, but the magnitude will be same. Okay, so let us define a free body diagram. So what is a free body diagram? Any idea? Did you get any idea? See, such a diagram of body in which the body under consideration is free from all the contact surface and all the forces acting on it are drawn. That is called free body diagram. I'll just say once more, just try to understand from this concept. Okay, all the forces acting on this object, all the forces acting by this object is free from its contact surface and the force are drawn. Okay, so this is an example you see here. Now, let us take few more examples of this free body diagram. And remember that weight is W is equals to m into g and force is a vector quantity. Then the magnitude of this weight or action should be equal to this reaction. Okay. Now let us take few more example of this FBD or free body diagram. And let us draw in a table. Okay. Let us draw in the form of a table. That will be good for you. Reacting body, okay, it's a reacting body, FBD, for what? For which object? First one is what? Reacting body. Second one is called FBD, required for, and last one is FBD diagram. FBD. So here we have three tables. This FBD diagram is very important. Okay. So if at all you know how to find the FBD of an object, you could go forward, because you have to solve many problems which will be basic for this. And if you are civil, you have many reactions because of this. Okay. So let us take a classical example. The first one, what I taught you is a ball and a table. So this is my table and this is my ball. Okay. So I want to find FBD for ball. Means I should draw the FBD for this ball only. For this ball only. For this ball only. Okay, not for the table, but for the ball. Okay. So see, this is the ball. Okay, this is the ball, because we are drawing FBD for this ball. Okay, this ball has certain weight, and I told you that weight always act vertically downward, and let it be as my weight. You remember that W is equals to mass into gravity. Now, that is the force acting by the ball onto this table. Now, there will be another force of same magnitude but opposite in direction by this table or by the surface. This is my reaction R. Okay. See, I'll say once more. This weight of this object or weight of the ball always act vertically downward. So I have written as W. And the reaction given by this table on the wall is R. So that is my FBD for ball. Next, we shall see another example. Okay. So this is my wall. This is my wall. Okay. And I am hanging a ball onto this wall with a string. Okay. This is my wall, and I am hanging this ball with a string. Now, my aim is to find FBD for again ball. This is my ball. Now, our aim is to find again FBD for this ball. See the diagram. This is my ball. This is my ball. This ball is lying onto the surface. Now, see at this point. At this point, ball and wall comes in contact. Okay. So at this point, the reaction will be produced by the wall and action will be produced by the ball on the wall. Okay. Now, this is my ball. This is my ball. Okay. If you could see here, first of all, weight of the ball will act vertically downward. So this is my weight of the ball which acts vertically downward. Okay. Now, since there is a thread or a string tied to the wall, there will be tension, or else this string is pulling the ball. Because of this string, the ball is in hanging position. So when the string is pulling the ball, it is under tension. It is under tension. So you see here, this is tension. That is the tension due to the string. Okay. Now, at this point, ball is in contact with the wall. So the reaction will be given by the wall to the ball. Okay, this will be my reaction. Now see, no force are in exact opposite directions. Okay, so this is an example of a wall with a ball. If at all you have any doubt, please let me know in the comment, and please subscribe my channel. You know my name is Pandey Sir, Concept by Pandey Sir. So we shall see two more example of this. Okay, is this clear? Please let me know if you have any doubt. Okay, and please subscribe my channel, and even you can ask your friends or your family relatives to subscribe it. Okay, that could be a great help for me. So let us take another example. Okay, let us take another example. Okay, imagine this is a corner of the wall. So these are my wall, this is my corner of this. If total is my room, this is my corners of the room. Okay, now this corner has a ladder. This is my ladder. Okay, now, and a force or a weight of 600 Newton is acting on the ladder, and a force P is also acting on the ladder. See, what are the force acting on the wall? First of all, we'll have force due to the self weight of this ladder. Along with the self weight of the ladder, we have another weight of 600 Newton and a force of P. Okay, now FBD for what? We shall find FBD for ladder. Now, our aim is to find FBD for this ladder. If you could see this ladder, there are two contact points. This is my first contact point. This is my second contact points. Okay, so obviously here and here there will be reactions. At this point and at this point, you will have reactions. Okay, so let us find FBD for this ladder. See, this is my ladder. This is my ladder. First, the self weight of this ladder will act vertically downward. So this is my weight of the ladder, which is acting vertically downward. Along with this self weight, there is an excess of 600 Newton. Okay, so even this will act vertically downward. Okay, any doubt? Now, at this point, it is in contact. So the reaction will be, see, if this is my ladder, the reaction will be from this side. Reaction will be given by the wall onto the ladder in this direction. In this direction, okay? In this direction. So this is my reaction. Let it be R1. Now, see here, there is again a ladder, and now it is in this position. Now my reaction will be in this direction. My reaction will be in this direction. See, it will be this direction. That will be my reaction. Okay. Let that be R2. Any doubt till now? Please look over it. Okay, that will be my reaction R2. Now, along with this, there's a force of P acting on this wall. It is in this direction. This. So here I'll write a force of P. Any doubt how to find FBD for the ladder? Now, we should see another example, okay? That's a wall. There is a pulley. That's a pulley which is being hung over to the wall. There's a weight. There's a weight. Let it be of how much? Shall we write 6 or how much? It will be 600 Newton. This is my surface. There is another block of weight. Let it be 400 Newton. You could see it. There's a pulley hinged to the wall which support a 600 Newton block and a weight of 400 Newton block. What is our question? FBD for block weighing 600 Newton. Our aim is to find FBD for this block. FBD for this block. If at all you see the first example, it's similar. This is my wall, this is my wall, okay, but here this is a string. So how to find it? First, let us draw a block of 600 Newton. So this is my block whose weight is 600 Newton. Okay. Any doubt? Next. See, since it is attached to the surface and this block is hanging, the self weight or the capital W will not be applicable in this. Since it is hanging, it will be applicable for this one. Here the weight do not come into action. But here you will have contact pressure. Means what? A reaction will be there. A reaction will be there. But self weight will not come into action because this is at rest and this one is hanging. So we have a reaction. To this reaction, it is being hung onto the pulley. So there will be a tension in the string due to weight of this one. Since this 400 Newton block is hanging, self weight will be applicable to this one. Okay. Since it is hanging, this string will be in tension. So the tension will be in this direction. That will be my tension. So this is FBD for this one. Okay now? Shall we see another example? Or else in the next video I'll be discussing about a new topic that's called Lami's theorem. Okay, that's called Lami's theorem. Okay, that is called Lami's theorem. Okay, in this theorem you can solve many problems. So stay tuned for my next video and please subscribe and like my channel. Thank you.